So let's talk a little bit more about materials. In some of the discussion earlier, you mentioned that fiberglass isn't particularly great, especially things with large percentage of glass. So what recap materials are compatible for use as C-band concealments, and can a combination of the materials be used to accommodate a site?
Sure. So we have a full line of materials that are all carrier approved for use for C-band concealments. We have, generally these are different types of composite materials that have been developed over the years, some of them more recently than others. We're generally on a per site basis selecting the best material to use for that specific application. So, for example, the type of concealment material that is capable of being manufactured into a radome for a pole or a small cell pole is not the same type of material that would be used for a rooftop screen wall. The two are not interchangeable. So, that's replayed over all the different concealment applications that are out there. Side-mounted boxes and clock towers, bell towers, and all the other ones that commonly come up. The general factors that we're looking at include the strength of the material, the thickness of the material, and what kind of environment it's going in. Strength is an especially important factor. It's something that's kind of overlooked a lot of times when RF engineers are considering what type of concealment material might be suitable for concealing, say, a C-band site. They're looking at the performance data of the exterior cladding material itself and not considering the strength of the material. And the reason that's important is because if you have a stronger material, it requires less structural supports to support that material. And ultimately, the signal from the radio, from the antenna, is generally going to have to transmit through these structural elements as well. So you have to consider it as an entire system. If you have a material that is only has to have structural columns in half of the locations as another material, that material is going to be a better performer, all other things being equal. These are a few things that we're considering, again, on kind of every site to determine the best possible material. And we have a lot of information on our website about those materials and the trade names for them and everything. But we feel we've got a very robust product line for concealment materials, and we're able to pretty much satisfy any requirement as far as the application and the cosmetic appearance that's required to virtually match any existing architectural feature for the purpose of building a concealment product that is suitable for C-band deployment.
Okay. Can you talk at all about the testing that you've done to sort of document, the efficacy of your materials?
Sure. So all the materials have been thoroughly tested. We're, having to look at some of the obvious parameters, that we talk about RF performance. This is a huge one. Will it allow the antenna to transmit, the signal to transmit through suitably? How much loss are we getting? Is there impact on the pattern that's coming off of the antenna? All of these things are RF performance parameters that we are testing on all of these materials. But there are a lot of other parameters to consider as well. You've got structural performance. I mentioned strength before, environmental durability, flammability. All of these are relatively obvious and usually have to be used in the engineering design for the individual project to ensure that we have a safe, long-lasting product. But there are some maybe softer properties that have to be considered as well for these, and testing that we do really for our own benefit, which is some simple things like, will an adhesive stick to it, right? There are a lot of composite materials out there that might be perfectly good for allowing antenna transmission, but if you can't adhere glue to it, then that becomes a problem. How difficult is it to fabricate and manufacture? Will common routers and other cutting tools cut it? Is it able to be field modified if it needs to be? What kind of thermal stability does it have? For deploying this in, say, a desert climate that has extreme high temperatures during the day and extreme low temperatures at night. What kind of durability does it have to withstand those temperature extremes day in, day out? So these are all tests that we're running before we consider mass deployment of any concealment material. And we have an R&D department that's consistently looking at this. Before we do the full structural RF testing and so forth, we're considering all of these softer parameters. But as they say, that necessity is the mother of invention, and generally when these come up, it's because a new technology comes down the road, like C-band or millimeter wave in more recent history, or we get a new application that we haven't considered yet, like something brand new concealment product that we haven't manufactured, and so we have to develop new materials to help satisfy those needs.
Okay. Well, then let's end by talking a little bit about that. I think the wireless industry is an industry that is always looking forward in some ways. So, what about future generations? Have you folks done any testing, to help carriers know whether the changes to concealments that are made now or new concealments are going to work for the next generation of wireless?
Sure, it's a great question. We're obviously heavily involved in the wireless industry, and we do our absolute best to stay informed about upcoming technologies, what's coming down the road, what new bands are going to be up for auction, and so forth. And as those are coming up, we're reviewing our existing products to ensure they're compatible. We definitely have testing data that supports not just the standard commonly used frequencies, but we generally test all the way across the board. So if we're going to look at whether a material is suitable for C-band, we're not just going to test for C-band. We're going to test from everything to the lowest to the highest frequencies that are commonly used. And so we have that data and that information on the shelf, so to speak, so that when these new bands and these new technologies are coming up, we can quickly look at that and determine, do we have a suitable material for this frequency? Or are we going to have to develop something new? And this is a strategy that we've used for a long time, and it's worked very well for us. And I think it puts us in a really good position to be able to help the carriers understand what impacts might be resulting from concealment as these new technologies are released.
Okay, great. Well, Trey, thank you so much for the time today and for sharing that perspective with us. It gives us a lot to think about in terms of concealment and some of the things that you have to think about as part of a wireless network.
Absolutely. Well, thank you very much for the time. It's nice to meet you, and I'm glad we could do this afternoon. Thank you.